So, let's dive into a story that's completely shaken up astronomy. It's about how everything we thought we knew about building planets, well, it's being turned on its head. Get ready, because it turns out the universe is way stranger and honestly, a lot more creative than we ever gave it credit for.
You know, for the longest time, the story of how planets form was actually pretty straightforward. We kind of used our own solar system as the main blueprint, right? You've got dust and gas swirling around a young star, and over millions of years, they calmly clump together to make rocky worlds and gas giants in these nice, stable orbits. It all made perfect sense.
But what if that's just one chapter in a much bigger, much wilder book? Because a whole wave of recent discoveries is showing us that the cosmos, well, it doesn't always follow our tidy little rulebook. In fact, it kind of seems to enjoy breaking the rules altogether.
Okay, let's start with the first broken rule. This one's all about where planets can even exist in the first place. See, for a long time, there was one type of stellar neighborhood that was considered a total cosmic no-go zone for planets.
And that neighborhood is a binary star system. Just try to imagine it. You've got two massive stars whipping around each other, creating this unbelievably chaotic gravitational mess. The logic was pretty simple. Any baby planet trying to form in there would either get torn to shreds or just flung out into deep space.
And this really lays it out for us. The old rule, the one we took for granted, said these systems were basically planetary deserts. But the new reality? We're finding that planets aren't just surviving there, they're actually thriving in some of the tightest binary systems we've ever seen.
So, meet the system that blew the doors off this rule, TOI 2267. Astronomers found 3 Earth-sized worlds here. Now, what's really wild is their setup. It looks like 2 of the planets are orbiting one star, while the third is orbiting its companion. If this gets confirmed, it's the very first time we've ever seen anything like it. This was supposed to be impossible.
And this isn't just some small adjustment to the theory, it's a fundamental rewrite. As one of the lead researchers, Francisco J. Pozuelos, put it, this discovery forces them to totally rethink how planets can form and stick around. It seems nature always finds a way. And the takeaway here? It's huge. This could potentially double the number of stars we can look at in our search for other Earths.
All right, so planets can pop up in chaotic places we never expected. But what about the one place we thought was the perfect safe haven for life? Let's move on to our second broken rule, because this one gets really interesting.
We've all heard of the habitable zone, right? The Goldilocks zone. It's been our #1 guide in the search for life. That sweet spot where a planet isn't too hot, not too cold, but just right for liquid water. It's the prime real estate we've been looking for.
Well, here's the catch. It turns out that a planet's address is only half the story. That just right zone can be sitting directly in the line of fire of a star's most violent tantrums, especially young active stars that blast their inner planets with ferocious high-energy radiation. It's a process called atmospheric escape. So first, the star just pummels the planet with this intense radiation. This energy gets absorbed by the planet's upper atmosphere, causing it to heat up and swell outwards, kind of like a balloon. And finally, that expanded, super vulnerable atmosphere just gets stripped away, bleeding a planet's air and all its water right out into the void. And to really get a sense of the scale of this threat, just look at this. Back in its early days, Earth got hit with a certain amount of this radiation. But a planet like AU Mike D, which is right in the habitable zone of its star, well, it gets blasted with about 1,000 times more. 1,000 times more. Let that sink in for a second. So a planet can be in the absolute perfect spot for liquid water, but if it's being constantly sterilized and having its atmosphere sandblasted off, well, the Goldilocks zone isn't so golden after all. This completely changes how we have to search for life.
So, we've got planets in impossible places and so-called safe zones that are actually super dangerous. What about the very process of building a planet itself? This brings us to our third and final broken rule.
When it comes to giant planets like our Jupiter, there have been 2 main competing ideas. The classic theory is core accretion. It's a slow, bottom-up process where a rocky core forms over millions of years, and then it's big enough to start grabbing gas. The other, less popular idea is called gravitational instability, a really fast top-down collapse where a huge chunk of the gas disk just collapses on itself and forms a planet in a flash.
Now, for a long time, core accretion was the clear frontrunner. But now, a young star system called AB Aurigae is giving us the first really solid observational evidence that this flash collapse method is very real.
So the evidence comes from this baby star, AB Aurigae, which is only about 4 million years old. And astronomers have spotted a protoplanet in its disk that's already 9 times the mass of Jupiter. According to that slow build model, there's just no way a planet that huge could have formed that quickly. The timeline, it just doesn't add up.
And here it is, the smoking gun. Researchers studying the gas found these little wiggles in its speed. And as Dr. Cassandra Hall points out, these wiggles are the hallmark signature that her team's simulations predicted for gravitational instability. It's direct proof of a giant planet forming in a chaotic, super-fast collapse. That means these monster worlds can appear way earlier than we ever thought.
So, okay, does this mean the old core accretion theory is just wrong? Well, not exactly. As it so often goes in science, it looks like the universe has more than one trick up its sleeve for building a planet. And even with 2 different ways to do it, we're finding things that neither one can quite explain.
Yeah, there are still these deep mysteries out there. For instance, there's this weird class of planets called eccentric warm Jupiters. These are gas giants in these strange, stretched-out oval orbits. But what's truly baffling is that they're almost always perfectly aligned with their star's equator, spinning on the same plane. No existing model, not the slow one, not the fast one, can explain this bizarrely consistent pattern. It just tells us we are still missing a huge piece of the puzzle.
So, when you put all of these broken rules together, what does it all mean? Well, a new picture of the cosmos is starting to come into focus. We're not just tweaking the old playbook here. It feels like we're writing a completely new one. The universe just isn't the calm, orderly place we once pictured. It's chaotic, with planets forming in gravitational minefields and in violent, sudden flashes. It's incredibly creative, finding ways to build worlds in places we had written off as barren. And it's shockingly resilient, with these systems holding together against all the odds.
And why does any of this matter? Well, it's not just trivia. Every single one of these discoveries fundamentally changes how we search for life out there. It forces us to broaden our definition of a habitable world and to look in places we used to just ignore. It helps us understand our own cosmic context, just how special, or maybe how average, our own little solar system really is. We've seen that the established rules for where planets can be, what makes a world safe, and even how they're built can all be broken. Which leaves us with a pretty thrilling and humbling question. What fundamental cosmic law is going to be the next one to fall?